A polynomial equation is an equation of the form f of x equals 0, where f of x is a polynomial. For example, 2x cubed minus 11x squared plus 10x plus 8 equals 0 is such polynomial equation. The function f of x is a polynomial on the left-hand side of that equation. Equations like this can be solved by factoring left-hand side, factoring the polynomial, and using the zero product property that says that if the product is 0, then it can happen only when one of its factors is 0. If the polynomial cannot be factored, then we'll use the technique of finding the zeros of the function f of x that we discussed earlier. We'll use the rational zeros theorem. So we look for, in this case, for this particular equation, the factoring is not going to work, so we are looking for the zeros of the function f of x. And to find those zeros, we'll start by looking at the rational zeros. The rational zeros can be found if they exist. They are of the form p over q, where p is the factor of 8 and q is the factor of the leading coefficient factor of 2. So these are the numbers. Factors of 8 are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Factors of 2 are plus or minus 1 and plus or minus 2. So the possible rational zeros for this function are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 1/2. We'll now check which one of those numbers is a rational zero, if any. So we'll start with x equal 1. Is the x equal 1 0 of the polynomial? So let's compute the value of function at 1. This is going to be 2 minus 11 plus 10 plus 8, and that is 9. This is not 0. So the answer to that is not a 0. Now let's try another one, x equal negative 1. If x is equal negative 1, the f of negative 1 is going to be negative 2 minus 11 minus 10 plus 8, which will be negative 15, again not a 0. So x equal negative 1 is not a 0. So let's go further along the list. X equal 2. If x is equal to, f of 2 is going to be 2 times 8 minus 11 times 4 plus 10 times 2 plus 8, and this is 0. So x equal 2 is a 0. And therefore, we can write my function f of x, or the polynomial, as x minus 2 times the q of x, where q of x is the quotient when dividing f of x by x minus 2. It can be shown using synthetic division that q of x is 2x plus 1 times, when factor, 2x plus 1 times x minus 4. And therefore, if I want to rewrite it in such a way that each factor represents 0, x minus 2 already represents the 0. 2x plus 1, I will have to factor 2 to get the form x minus c. So I will have x plus 1/2, and then x minus 4. Therefore, the zeros of f of x, and therefore solutions of the equations, are 2, negative 1/2, and 4. These are also solutions of f of x equals 0.